66 million years ago, a massive asteroid struck Earth, leading to one of the most dramatic extinction events in our planet's history. This catastrophic collision wiped out the dinosaurs, which had ruled the planet for over 160 million years, along with nearly 75% of all species. But this story isn't just about destruction. It's a tale that uncovers the hidden dynamics of our solar system, reveals the intricate processes that shaped life on Earth, and opens new questions about our place in the cosmos. The asteroid that caused this mass extinction wasn't just any ordinary space rock. Recent scientific breakthroughs have revealed that this cataclysmic impact was the result of a rare asteroid, one that originated from the outer reaches of our solar system, beyond the orbit of Jupiter. This discovery was made possible through advanced analysis of the Chicxulub impactor, the asteroid responsible for the creation of the 90-mile-wide crater in what is now the Yucatan Peninsula in Mexico. By uncovering the asteroid's genetic fingerprint, scientists have traced its origins back to the main asteroid belt, a vast region of space located between Mars and Jupiter. For decades, the precise origins of the Chicxulub impactor remained shrouded in mystery. Scientists knew it was a part of our solar system, but the lack of clear chemical evidence made it difficult to pinpoint its exact origin. The challenge lay in the fact that Earth's own geological processes often contaminate extraterrestrial material, making it hard to identify the asteroid's unique characteristics. However, researchers recently overcame this obstacle by developing a new technique that allowed them to isolate and analyze the chemical composition of remnants of the Chicxulub impactor. These remnants, found in the Earth's crust, revealed the presence of a rare element, ruthenium. Ruthenium is a precious metal, and in this context, it serves as a genetic fingerprint for asteroids in the main asteroid belt. The specific isotopic signature of ruthenium found in the Chicxulub impactor matches that of carbonaceous chondrites, a type of meteorite that originates from the outer regions of the main asteroid belt. This region is a relic of the early solar system, a place where planets and asteroids were formed from the primordial dust and gas that surrounded the young sun. The discovery that the Chicxulub impactor came from this distant part of the solar system suggests that the asteroid was likely nudged out of its stable orbit and sent on a collision course with Earth. But what could have caused this asteroid, which had remained in the asteroid belt for billions of years, to suddenly veer toward Earth? The answer lies in the complex gravitational interactions within our solar system. The main asteroid belt is not a quiet, unchanging place. It's a dynamic environment where collisions between asteroids are common and where the gravitational influence of nearby planets, especially the gas giants like Jupiter, can send shockwaves through the belt. These gravitational forces can disturb the orbits of asteroids, causing them to spiral inward toward the inner solar system. In the case of the Chicxulub impactor, it's believed that a combination of these factors, perhaps a collision with another asteroid or the gravitational pull of Jupiter, disturbed its orbit and sent it on a deadly trajectory toward Earth. This was no ordinary rock. It was a city-sized asteroid, traveling at tens of thousands of miles per hour, carrying enough energy to unleash a global disaster upon impact. When this asteroid struck Earth, it did so with unimaginable force. The energy released by the impact was equivalent to billions of atomic bombs detonating simultaneously. The immediate effects were devastating. A massive fireball incinerated everything within hundreds of miles, while the shockwaves triggered massive earthquakes and tsunamis that rippled across the planet. But the most far-reaching consequence of the impact was the release of vast amounts of dust and sulfur into the atmosphere. This fine particulate matter blocked out sunlight, plunging the Earth into a prolonged impact winter. Temperatures plummeted and photosynthesis became impossible, leading to the collapse of ecosystems around the world. The impact winter was a critical factor in the mass extinction that followed. Without sunlight, plants died off, and the food chains that depended on them collapsed. Herbivorous dinosaurs, which were already struggling to survive the initial devastation, found themselves without food, and the carnivorous dinosaurs that hunted them soon followed. Within a few years, nearly all non-avian dinosaurs were extinct. However, this global catastrophe also paved the way for the rise of mammals, including our distant ancestors. With the dinosaurs gone, mammals began to thrive in the new ecological niches that opened up, eventually leading to the evolution of humans. The Chicxulub impact is a stark reminder of the potential dangers that lurk in space. Asteroids of this size and destructive power are rare, but they are not unique. In fact, scientists have identified several other large impact sites on Earth, including the Vredefort crater in South Africa and the Sudbury Basin in Canada. These ancient impact sites serve as a testament to the ongoing bombardment of our planet by space debris over the course of its history. One of the most intriguing aspects of the Chicxulub impact is that it may not have been an isolated event. Some researchers suggest that Earth has experienced periods of increased asteroid activity in the past, possibly due to the gravitational influences of nearby stars or the movement of our solar system through the galaxy. These periods of increased activity could have led to multiple impacts over a relatively short period of time, potentially triggering mass extinctions and shaping the course of evolution on Earth. The study of asteroids like the Chicxulub impactor is crucial for understanding the history of our planet and the threats we may face in the future. By studying the chemical composition and origins of these space rocks, scientists can improve their ability to predict and mitigate the effects of potential asteroid impacts. This research has direct implications for planetary defense strategies, which aim to protect Earth from future asteroid collisions. One of the most promising developments in this field is NASA's Artemis program, which aims to return humans to the Moon and establish a sustainable presence there. One of the key objectives of the Artemis missions is to collect lunar samples that contain the ancient, unchanged remnants of the asteroids and comets that bombarded both Earth and the Moon in their early history. These samples could provide invaluable insights into the composition and behavior of these ancient space rocks, helping scientists to better understand the dynamics of asteroid impacts and improve their predictions of future threats. The Artemis program represents a new era in space exploration, one that could lead to groundbreaking discoveries about our solar system and its history. As we gather more data from these missions, we may finally be able to answer some of the biggest questions about the Chicxulub impact and the broader processes that have shaped our planet. Could there be more giant asteroids lurking in the outer reaches of our solar system, waiting to be discovered? What other cosmic events have influenced the course of life on Earth? And how can we protect our planet from future impacts? These are questions that scientists are eager to explore, and the answers could have profound implications for our understanding of the universe. The story of the Chicxulub impact is far from over, and as we continue to investigate the origins and effects of this catastrophic event, we may uncover new insights that change the way we see our place in the cosmos. So as we look to the stars and prepare for the next era of exploration, we should remember the lessons of the past. The Chicxulub impact was a turning point in the history of life on Earth, but it was also a reminder of the fragility of our existence in the face of cosmic forces beyond our control. As we continue to explore and learn, we must remain vigilant and prepared for the challenges that lie ahead. The universe is vast and full of mysteries, and our journey to understand it has only just begun.